subtracting real numbers. If we say that a and b are real numbers, then a minus b is the same thing as a plus the opposite of b. Essentially, one way to think of subtraction is to change every subtraction problem to an addition problem of the opposite. And if we will do so, the same rules we learned in the previous section will apply to all of these subtraction problems. Let's try to go through these first three examples and see how that's true. So we start with 4 minus 7. We can rewrite this as 4 plus the opposite of 7, or 4 plus negative 7. Remember the rules from the last section. If we have two values that differ in sign, we have one positive value, one negative value, we start by subtracting the largest absolute value, which is 7, and the smallest absolute value, which is 4. 7 minus 4 is 3. We then assign the value from the largest absolute value. So the largest absolute value, 7, came from negative 7. For that reason, our answer will be a negative 3. Let's try the same process on the next example. Negative 8 minus negative 9. We want to first change this to an addition of the opposite. So negative 8 plus the opposite of negative 9. The opposite of negative 9 is a positive 9. So we have negative 8 plus 9. Again, we have two different signs, one negative, one positive. So we subtract the largest absolute value. We say the largest absolute value minus the smallest absolute value. 9 minus 8 is 1. And that 1 needs to carry the sign from the largest absolute value. Here, the largest absolute value came from a positive 9. So our answer will carry that sign. We have a positive 1. The same is true when we have more than two numbers. We could have 3 numbers, 4 numbers in a row that we are subtracting. Every time we will add the opposite. So in example C, we have negative 5 minus 6 minus negative 3. Let's change these minus signs to addition of the opposite. So we start with negative 5 plus the opposite of 6, which would be negative 6, plus the opposite of negative 3, which would be positive 3. Now, following order of operations, we know we always add from left to right. So we add the first two values, negative 5 and negative 6. Remember the rule from the last section. If both of our signs are the same, we add the absolute values of those numbers and keep that common sign. So the absolute values here would be 5 and 6. 5 plus 6 is 11. And the common sign was a negative sign. So negative 5 plus negative 6 is negative 11. To add negative 11 and 3, we first recognize that they have different signs. 11 is negative, 3 is positive. So we form a subtraction problem with the largest absolute value, 11, minus the smallest absolute value, 3. 11 minus 3 is 8. But positive 8 won't be the answer. We see that the largest absolute value came from negative 11. So we assign that negative value to the answer. And our answer in this problem is negative 8. Let's try a few more examples. And here I'm going to show you one shortcut when we are subtracting a negative. 6.9 minus negative 1.8. Whenever you see two negative signs back to back, that will become an addition with a positive number. So we can rewrite this as 6.9 plus 1.8. The exact same concept of adding the opposite. But in the case where two negatives, or we are subtracting a negative, it will be the same as adding a positive value. So we add 6.9 and 1.8, and the sum is 8.7. That will be a positive 8.7 because both 6.9 and 1.8 were positive values. For part B, we have -3/4 minus -4/5. And the same trick that applied to part A applies here. We are subtracting a negative, which is the same thing as adding a positive. Now, before we can go through this process, we notice we have a positive number and a negative number, but because they are both fractions, we need a common denominator. So we find the least common multiple of 4 and 5, because those are our denominators, go through the process that was taught in Module 1, and the least common denominator will be 20. So we rewrite each of these fractions as equivalent fractions with a denominator of 20. Again, this is a concept that was taught in Module 1, Section 2. So -3/4 is equivalent to -15/20. 4/5 is equivalent to 16/20. And now that we have a common denominator, we can add. We write the common denominator once, and we apply the operation to the numerator, -15 plus 16. Because 15 and 16 have different signs, we take the largest absolute value, 16, and subtract the smallest absolute value, 15. 16 minus 15 is 1. The largest absolute value came from a positive number, so this would be a positive 1. So the difference here is 1/20. Let's continue using the same steps in the previous problems to simplify each of these expressions. In example A, we have -9 minus 5 plus 11 minus -7. So we begin by changing every subtraction sign to addition of the opposite. We have -9 plus the opposite of 5 is -5 plus 11. We already had an addition symbol. Plus the opposite of -7 is +7. Or you may have recognized that we were subtracting a negative, so we must add a positive. Going through our order of operations, we have all additions, so we go from left to right. -9 and -5 both have the same sign, so we add the absolute values, which is 14, and we keep the sign. Still going from left to right, we have -14 and +11. We have different signs, so we subtract the larger absolute value, which in this case would be 14, minus the smaller absolute value, which in this case would be 11. That subtraction gives us 3. And since 14 had the larger magnitude, it will be -3. Finally, adding -3 and 7, we have different signs again. The larger absolute value, 7, minus the smaller absolute value, which is 3, would give us 4. And because 7 had the larger magnitude, we'll have a +4 for our answer. In the next example, we see that we have some grouping symbols. Before we go and take care of the grouping symbols and go through the order of operations, let's change every subtraction to addition of the opposite. So we start with 3 squared. Instead of minus, we're going to say plus the opposite of 8, which is -8. Plus, we write our square bracket, -5 minus, instead of that minus sign, we put plus the opposite of -9, or plus +9. Again, you may have recognized that we were subtracting a negative, so we needed to add a positive. Now that we've changed all of our subtraction to addition, let's start going through the order of operations. So we start with the grouping symbols. And inside the grouping symbols, we have -5 plus 9. The signs are different, so we subtract the absolute values, and that will give us 4. The larger absolute value came from a positive number, so it will remain a +4. Everything else stays exactly the same. Now that we've finished the grouping symbols, we go to exponents. And we see one exponent at the beginning of the expression, 3 squared, and 3 squared equals 9. Again, everything else stays exactly the same. Now that we have only addition in our expression, we add from left to right. 9 and negative 8 have different signs, so we subtract the absolute values, and that gives us 1. And that would be a positive 1 because 9 had the larger absolute value. Our last two numbers have the same sign, so when we add the absolute values and keep that sign, and we have the answer. Let's now try to translate and simplify each expression. Remember, we had a table of words that represented different operations in the last module homework, or maybe 2 sections ago. Hopefully you copy that into your notes. If not, you will need to do so, because every time we translate, we will need to know those key words that we're looking for. So in part A, we have the phrase subtract 25 from negative 19. Again, anytime you see the phrase subtract from, the first thing that should pop into your mind is reverse. We know we need to subtract, but we have to do so in reverse order. So instead of 25 minus negative 19, this will actually be negative 19 minus 25. Now that we've translated the statement, let's simplify. We first change all of our subtraction to addition of the opposite. Once we do so, we see that 19 and 25 have the same sign. They are both negative. So we add their absolute values, and we keep the sign. Let's try to translate part B. A commercial jetliner hits an air pocket and drops 206 feet. After climbing 153 feet, it drops another 183 feet. What is its overall vertical change? Now, in this example, anytime we see the word drops, that's going to be represented by a negative value. Anytime we see the word climbing or climbs, that will be represented by a positive value. So let's add all of our positive and negative values together to find out what its overall vertical change was. We have negative 206 plus a positive 153 plus negative 183. Following order of operations, we start from left to right. So we have two opposite signs. 206 is negative, 153 is positive. So we subtract the larger absolute value minus the smaller absolute value. That gives us 53. But because the larger absolute value came from the negative number, this would be a negative 53. Now we want to add negative 53 and negative 183 because these share a common sign. Add the absolute values, and we keep that common sign. So the overall vertical change of this commercial jetliner is negative 236 feet. Let's try another example, and in this example, we're going to find the value of an expression. So given the expression x minus y, all divided by 17 plus x, when x equals 4 and y equals negative 3. So remember, the first step when we want to evaluate an expression is to plug in the values for the variables. And it's best to put those values in parentheses, at least initially. So in place of x, we put 4. In place of y, we put negative 3 on both top and bottom. After doing so, let's change all subtraction to addition of the opposite. So in the numerator, and because 4 is in parentheses and it's a positive number, I'm going to go ahead and drop those parentheses. We're safe in doing that. So we have 4 plus the opposite of negative 3, which is 4 plus positive 3, all over 17 plus 4. Remember, the fraction bar in this case is a grouping symbol that separates the numerator from the denominator. So let's work the numerator first. 4 plus 3 is 7. 17 plus 4 is 21. And anytime we deal with fractions, we want to make sure our fraction is written in lowest terms, or that it is simplified as far as it can be. So we write the prime factorization of the numerator and the denominator, and that gives us 7 over 3 times 7. You see we have a common pair of 7s that can be canceled. So we write the placeholder 1 in the numerator over 3, or 1/3. We have one more definition that will be necessary to work this next example, as well as other examples in later modules. Complementary angles. You may have seen this term before. But complementary angles are two angles whose sum means plus, is 90 degrees. So in this example, we want to find the measure of the following complementary angles. So we're given two angles. We have x, we have 37 degrees. And we know because they are complementary, they should add up to 90. So since we were given one of the angles, we should be able to find the second angle by subtracting. We start with 90 degrees, the total of both angles. We subtract the angle we know, and that will give us the unknown angle. So now we can simply subtract 90 minus 37. And we determine that the unknown angle is 53 degrees. Again, we need another definition in order to work this last example, and that would be the definition of supplementary angles. Supplementary angles are two angles whose sum, again, they add up to 180 degrees. So again, we want to find the measure of the following supplementary angles. One of the angles is given as 123 degrees. The other angle we don't know, but in a similar process that we saw in the last problem, we can take the full 180 degrees, subtract the known angle, and that will give us the unknown angle. So now we simply subtract 123 from 180, and we determine that the unknown angle measures 57 degrees. Work hard on this section's homework and make sure to ask questions as they arise.